In this video, I'll be solving another dimensional analysis problem. This will also involve metric units, which differ by a prefix, but in this case, we will have to figure out the conversion factor and the relationship between the units ourselves. So as we see in this problem, we are starting with 0.71 liters, and we're trying to convert this to milliliters. We would like to know the relationship between liters and milliliters in order to solve this, but it's not going to be given with this problem. The way that we will do this is based on what the prefix milli means. We see that both of these units involve liters, but one has that extra prefix, the lowercase m here, which represents the prefix milli. If you look on a reference, which you can do until you are expected to have the values memorized, milli is a prefix that represents 0.001, written as a normal number, or we could also write this as 10 to the negative third power. We're going to use this to figure out how liters and milliliters are related to each other, and we will do this based on a substitution method. In order to use the substitution method, what we will first do is write a simple equation where we have the unit with the prefix, in this case that's milliliters, and we'll set it equal to itself. So we'll say milliliter equals milliliter. We know this is true because anything is going to be equal to itself. To figure out how milliliters and liters are related, we will keep one side of this equation the same, so I'll just go ahead and copy the left side as just milliliter. But on the second side, we're going to take the milli portion, the m, and replace it with the value that is equal to it. We know that milli is equal to 0.001, and so we can replace the milli part with 0.001, leaving the liter part untouched. What this tells us is that milliliter is equal to 0.001 liters, or another way to put this is that 1 milliliter is equal to 0.001 liters. This is going to be important for us because now we have the relationship between the two units that we can use in our dimensional analysis. So I will copy this to the top. And we will be using this as we do our problem. Now that we have the relationship we need, we can go back and set up the dimensional analysis the way we would have done in any other problem. So since we have that we are starting with 0.71 liters, we'll start there. And as before, we're going to put this over 1, just to make it into a fraction so it's easier to multiply by our conversion factor. Then we know that our conversion factor is going to be some fraction that we're multiplying by. Using dimensional analysis, we can see that since we start with liters, we are going to need to cancel that liters by putting liters on the bottom of our conversion factor. The liters on top and liters on bottom will cancel with each other, and we know that milliliters must go on top of our conversion factor so that we have the appropriate units shown together. Then we'll need to plug in the numbers with each unit. We can use our relationship that we found in the previous part, that 1 milliliter is equal to 0.001 liters. And so that means that we'll have 1 milliliter on top and 0.001 liters on the bottom. This should now be set up completely, and so we should be able to solve. We know that the units will cancel properly. We have the liters on top canceling with liters on bottom, leaving us with milliliters like we want. And when we calculate the numbers out, we should find that we will end up with 710 milliliters. And that should take us through the problem. So hopefully these examples of dimensional analysis have been helpful. And now be sure that you get plenty of practice with this because it will be a very important skill as we move forward in this class.